Dear students of the third prep grade, and welcome to a new episode of our program. It's time for mathematics, and on this episode we'll be discussing and explaining lesson 2 of unit 2 of algebra, ratio and proportion with our teacher of mathematics, Mr. Ashraf Ahmed Helmi. Hello, Mr. Ashraf, and welcome to the program.
Thank you.
Do we have any introduction to this lesson before we get started with it?
Yes, actually we had an introduction for the last episode, and we talked about what they mean by a ratio and what they mean by a proportion, and we studied some properties about the proportion. Today we are going to complete the properties of the proportion, and let's start with the last two properties that we studied for the last time. And we said before that when I said 3 over 4 equals 6 over 8, this is a proportion.
Yes.
And we may have some names for these numbers, as this is the first proportion, this is the second, this is the third proportion, and this is the fourth proportion. And we said before, if we have a over b equals 3 over 4, it doesn't mean that a is equal to 3 and b is equal to 4. It means that a equals 3 times the factor m, and b equals 4 times the factor m, where m doesn't equal 0. And what do we have for this time? That if we have a proportion of a over b equals c over d, so this means that a it's equals to c times the factor m, and b equals d times the factor m, where m doesn't equal to 0. So this is the main property that we are going to work on for this episode.
Of course, on our previous episode we talked about the difference between this same lesson that they studied in primary 6 and that one they are studying this year.
Yes, of course. And let me show you an example on this. For example, if we, in our pupil book, page 29, exercise number 3, we had an exercise here, and we can answer this exercise in the old fashion for 6th primary and for the new fashion for 3rd prep.
All right, this exercise says if A to B to C equals 5 to 7 to 3, and A plus B equals 27.6, then find the value of A, B, and C.
Okay, for the old fashion, for A to B to C is 5 to 7 to 3, so we are going to write here 5 to 7 to 3. And the sum of B and C, so I'm going to put here or sum of A and B, and the sum of A and B is 27.6, I'm going to write it here, 27.6. So I'm going to have the sum of A and B, which is 12. And now, using a cross multiplication strategy, I can find the value of C and B, as C will be equals to 27.6 times 3 divided by 12, and B equals 7 times 27.6 over 12, and A equals 5 times 27.6 over 12. And this is what we have for 6th primary. But for 3rd prep, we have a new way to solve something like this. So we have here A to B to C. And for A to B to C, we have the ratio between these numbers is 5 to 7 to 3. So simply, I can write that A will be equals to 5 times the factor m, and b will be equal to 7 times the factor m, and c equals 3 times the factor m, and this factor m doesn't equal to 0. And we have here as a given a plus b equals 27.6. So all what I'm going to do that I'm going to add 5m plus 7m, which is 12m, equals 27.6. Now to find the value of m, I'm going to divide 27.6 divided by 12, and the factor here m, it will be 2.3. I got the factor, so I can find a, b, and c. I'm going to replace m by 2.3 to find a, b, and c. So a equals 5 times 2.3, b equals 7 times 2.3, and c equals 3 times 2.3, and the answers here will be the same as we did before for the last page.
All right, so that is the answer to exercise 3, page 29. We answered it in the old-fashioned way, the one you studied in elementary 6, and the one you studied this year. So let us move now to another exercise. It's the same page, page 29, exercise 5. All right, and it says if x over 3 equals y over 4 equals z over 5, then prove that a 2y minus z over 3x minus 2y plus z equals 1 over 2.
Yes. For this exercise, I can rewrite the given here, which is x over 3 equals y over 4 equals z over 5. I'm going to write this proportion in a new way as x over y equals 3 over 4. And this means that x equals 3 times the factor m, and y equals 4 times the factor m, and this factor doesn't equal to 0. And again, I can write this proportion y over 4 equals z over 5 in another way as y over z equals 4 over 5. So this means that y equals the same value here is 4m, so I can use the same factor here, 4m, and z equals 5m, where m doesn't equal it to 0. As long as y have the same values here, which is 4 times the factor m, and here's y times the factor m, I'm going to write it as this way. I will not use a combining ratio to find the value of y. Now, so in this type, I have two values for x, y, and z. I have x equals 3m, y equals 4 times m, and z equals 5 times m, and m is a factor, and this factor doesn't equal to 0. Now, to prove that for letter A, I'm going to work on the left-hand side, as the left-hand side is 2y, which means 2 times 4m. I'm going to replace y by 4m, minus z, which is 5m, over 3x, so 3 multiplied by 3m, minus 2y, which is 2 multiplied by 4m, as I'm going to replace y by 4m, over here plus z, which is 5m. Okay, simplifying the like term, so 2 times 4m, which is 8m minus 3m, the answer in the numerator will be 3m, over, and here's 9m minus 6m plus 5m, and the answer, minus 8m, I'm sorry, plus 5m, and the answer it will be 6m, and I'm going to simplify, the answer it will be 1 over 2, which is the right hand side. So I have finished exercise 5, letter A. As we
All right,
see.
the second part, B, says root 3x power 2 plus 3y power 2 plus z power 2 equals 2x plus y. And this is again exercise 5, page 29.
I'm going to use the same, given that I got it before, that x equals 3m, y equals 4m, and z equals 5m. And m is a factor, and this factor doesn't equal to 0. Now, here for the left-hand side here, I'm going to work on the left-hand side, which is root 3x, so I'm going to multiply 3 by x squared. So x here is 3m, so x squared, it will be 9m squared, plus 3 times y squared, and for y squared it will be 16m squared. So this is 16m squared, plus z squared, which is 25m squared. Okay, I'm going to simplify, as we have 3 times 9m squared, which is 27m squared. So we have here 27m squared plus 3 times 16, and the answer it will be 48m squared plus 25m squared. So 27 plus 48 plus 25, the answer is 100m squared. So we have square root 100m squared, so the answer here is 10m. So this is the left-hand side for this part, which is 10 times the factor m. Now we are going to work on the right-hand side. I'm going to use another page. So for the right-hand side, which is 2x plus y, so I'm going to replace x by 3m, plus 4m, which is the y. So 2 times 3m, the answer here is 6m plus 4m, the answer is 10m. So the right-hand side is the same as the left-hand side, so we got that this identity is right.
Mm-hmm. All right, let us now, Mr. Ashraf, go back to exercise 4, page 29, which says if x, y, and z, and is it L?
Yes.
Right? And L are proportional quantities, then prove that A, x plus y over z plus L all power 2 equals 2x power 2 minus 3y power 2 over 2z power 2 minus 3l power 2.
As a very important given here, which is x, y, z, and L are proportion, we are going to rewrite this given in another way as x over y equals z over L equals a factor m. And this means that x equals y times m, and z equals L times m, and m doesn't equal to 0. So I'm going to use these two givens, or these values for x and z, and replace them for the left-hand side and the right-hand side in letter A. So I'm going to work on the left-hand side. As for the left-hand side, it's x minus y, so ym minus y over z minus L, so z it's Lm minus L all power 2. So I'm going to have a common factor up here, which is y, so y times m minus 1 over L as a common factor, L here for these two terms, times m minus 1, and all of this to the power of 2. Simplifying, m minus 1 and m minus 1 are two factors in the numerator and the denominator. So the right answer here, it will be y over L to the power of 2, which is y to the power of 2 over L to the power of 2. Okay. Now I'm going to work on the right-hand side. So for the right-hand side, we have 2x squared. I'm going to write it here. So this is for the right-hand side. And for the right-hand side, we have 2x squared. So I'm going to replace x by y. So it's 2y squared m squared minus 3y squared over, down we have 2z squared, which is 2l squared. I'm going to use another color. 2l squared m squared minus 3l squared. As you see, I replaced z by lm, and here I replaced x by ym. Now we have a common factor over here, and the common factor here which is y squared. So I'm going to write this as y squared times 2m squared minus 3 over l squared times a common factor here for these two terms, which is l squared. So we have here 2m squared minus 3, and I'm going to simplify these two factors. So the answer, it will be y squared over l squared. So the left-hand side is the same as the right-hand side. I want to say something about this, that for some books with the old version, the question here is written plus for the left-hand side and plus here over here.
X plus y?
Yes, but the new version one is x minus y over z minus l. This is for the new version.
Okay, so this is very important. It's x minus y, not x plus y.
Yes.
This exercise 4. Now let us move to the second requirement, which is it cubic root?
Yes, it's
right. Cubic root 5 x power 3 minus 3 z power 3
yes.
over 5y power 3 minus 3l power 3 equals x plus z over y plus l. And of course you have this exercise in your book, page 29, exercise 4. We had already A, and now we're doing B.
Okay. For B, I would say something else. For the new version books, the right answer for the left-hand side is x minus z over y minus l. But for the old version, it's x plus z and over y plus l, and this is wrong one.
Okay.
But the right is x minus z over y minus l. So we have here for the left-hand side, I'm going to work on the left-hand side. I have here the same two rules that I got them from a very important line here, which is if x, y, z, and l are proportional. So we have x equals y times m, and z equals l times m. For the left-hand side, we have a cubic root. So this is a cubic root. 5x. So x power 3 actually, so 5 times x power 3, which is ym. So y to the power 3, m to the power 3, as a very important property for the powers, as x power 3 is the same as y power 3, m power 3, minus 3 z power 3. And for z power 3 is the same as l power 3, m power 3. So I'm going to replace here z power 3, m to the power 3, over 5y to the power of 3, or 5y cubed, which is 5y cubed here, and minus 3l cubed. This is l. Now, I have a common factor here for the numerator, and the common factor here is m power 3. So cubic root m power 3 times 5y power 3 minus 3l power 3 over down 5y power 3 minus 3l power 3. Now let's simplify. And to simplify something like this, I'm gonna simplify these two factors. So the answer it would be cubic root m power 3, and the answer is m. Okay. For the right hand side, which is x minus z over y minus l. So I'm going to replace x by ym minus z, which is lm, over y minus l. Now I'm going to have m as a common factor, which is y minus l here for the numerator, over y minus l. I can simplify y minus l up and down, so the answer it will be m. So here, for the right hand side, is the same as the left hand side. So we proved what we have here in this exercise.
All right, now let us move to page 35, and we have here exercise 8. All right, exercise 8, page 35, which says if x over 2a plus b equals y over 2b minus c equals z over 2c minus a, then prove that 2x plus y over 4a plus 4b minus c equals 2x plus 2y plus z over 3a plus 6b. This is again exercise 8, page 35. Okay.
Before going on this exercise, this is a new kind of proportion for third prep.
Yeah.
So I'm going to explain something to our students, that if we have 3 over 4 equals 6 over 8, as you see here, I multiplied 3 by 2 up and down, so we have a new ratio which is 6 over 8. The new thing that we have here, that if we add the numerators and the denominators down, so we have a new new ratio which is 9 over 12, and we surprised that in adding the antecedent or the numerators together and the denominators together, we got a new ratio equals to these two ratios, which is 9 over 12. And it's the same as if we subtract the antecedents and the consequence. So we have in the numerator -3, and down 4 minus 8 is -4, and the ratio between these two numbers is the same as 6 over 8, 9 over 12, and 3 over 4. And let's have an exercise on this, as, for example, if we have x over 3 equals y over 4 equals z over 5, this will be the same as x plus y plus z over 12. And for 12, it's 3 plus 4 plus 5, so the answer is 12 here. And will be the same as, for example, x minus y plus z. And down in the denominator, I'm going to write here 4, as 3 minus 4, it's -1, plus 5, this is 4. And let me write an exercise here before going on this. If we have x over 3 equals y over 4 equals z over 5, and this equals to, for example, 2x minus y. So what do we have here in the denominator? Actually, as we see here, we have 2x minus y, so I'm going to multiply 2 for this ratio up and down, multiply by 2, and subtract the result down, -4. So 2 times 3, it's 6 minus 4, so the answer is 2. And for another example, if we have x over 3 equals y over 4 equals z over 5 equals, down here we have, for example, 9. And so what do we have in the numerator? Actually we have many answers. We can write it here as 9, as I'm going to multiply the first ratio up and down by 3, so I can have 3x here in the numerator. So we have an answer here which is 3x. Or maybe some students will say that 4 plus 5 gives me 9, so I can write up here y plus z. So these two answers are right. Now let's go on exercise number 8, page 35.
Let us now see how this info can be useful in solving this exercise. Again, it's exercise 8, page 35, okay?
Okay, I'm going to write the given. I have 3 equal ratios, and this is over 2b minus c equals z over 2c minus a. And these 3 equal ratios, I'm going to name them as, this is the first ratio, this is the second ratio, and this is the third ratio, and this is a proportion. So for the left hand side in the proof, as you see, we have in the numerator 2x plus y. So I'm going to use the first ratio and multiply it up and down by 2. So we have 2 times, as here's 2x, I'm going to multiply here by 2, so I'm going to multiply down by 2. So this is 2a plus b. Then we add this to y, which is the antecedent of the second ratio. So I'm going to add this to y, which is 2b minus c. And of course, this equals one of these ratios, as we studied before for the last paper. This is equals one of the ratios. So we have here 2x plus y over, I'm going to use the distributive property to find the answer of this, which is 4a plus 2b plus another 2b minus c, which equals to 2x plus y over 4a plus 4b minus c, and this equals one of the ratios. As a very important rule we studied now, it's that if we have any operations for the antecedents and the consequence, we have a new ratio equals to one of these ratios. So this is for the left hand side. I got the left hand side. Now I'm going to work on the right hand side to find what should I do here. I have the right hand side. So for the numerator we have 2x plus 2y plus z. So I'm going to multiply 2 by x, so I'm going to multiply the consequent of this ratio 2 times 2a plus b plus 2y, so I'm going to multiply 2 by 2b minus c plus z, which is 2c minus a. And this equals one of the ratios, of course. Okay, let's simplify now. For the numerator, we have 2x plus 2y plus z. And for the denominator, I'm going to use the distributive property to find the values of these. So this is 4a plus 2b. And this is 4b minus 2c. And this is plus 2c minus a. Now we have some like terms. Negative 2c and plus 2c, and they vanish together. And we have 4a minus a, the answer is 3a. So this is equals 2x plus 2y plus z over 3a. And here is 2b plus 4b, and the answer is 6b. So now this ratio equals one of the ratios. And as you see here in this part, as we worked on the left hand side and we used the new property, we got the left hand side, which equals to one of the ratios. And for this part here, we worked on the right hand side and we used the same property. We got a new ratio which equals to one of the ratios. So we proved now that the left hand side is the same as the right hand side.
All right, shall we now move to page 36?
Okay, of course.
All right, so it's page 36, and let us have exercise 1, which says if a plus b over 3 equals b plus c over 6 equals c plus a over 5, then prove that a plus b plus c over a equals 7. This is again page 36, exercise 1. So, do you think this is an easy one, Mr. Ashraf?
How do you know it's easier?
Yes, usually the first
yes,
exercise is easy.
No, actually, it's the hard one.
It's not.
So as you surprised me, as you asked,
Yeah.
is it the easy one? So it's not. Actually, we have 3 ratios, and this is a proportion. And this is the first ratio, the second ratio, and the fourth ratio. And we want to prove that that A plus B plus C over 7 is the same as A over 1. And some students will be surprised, where is this given? It's not this given, or it's not the required that it's written in the question. Actually, we changed the required in this form, so I can work on the givens to find this form. Then I'm going to back again to this form to write it, what we have here in the required. A plus B plus C over 7 equals A over 1. This is what do we need. I changed the required. I wrote it in another form. So how can I find A plus B plus C over 7? Simply, what I am going to do, I am going to add all the antecedents, and I'm going to add all the consequents, and sure this will be equals to one of these ratios, as we said before. So I'm going to add A plus B plus C plus C plus A over. These are the antecedents of the 3 ratios. 3 plus 6 plus 5. And this is for the left-hand side. So, for the left-hand side here, we have the like terms. So A plus A, we have 2A. And double B, we have here 2B. And for double C, we have 2C over 3 plus 6 plus 5. And the answer here is 14. A common factor here, 2. So I'm going to write, I have a common factor 2, open bracket, A plus B plus C over 14. Using simplifying, so A plus B plus C over 7, this equals one of the ratios, and this is what we have here for the right-hand side. So we got for the right-hand side, A plus B plus C over 7 equals one of the ratios. We had a new ratio equals to the ratios which are written in the given. For the right-hand side, I'm going to use another color. The right-hand side. And the right-hand side is A over 1. And how can I get A over 1? Actually, I'm going to use the first 2 ratios. I'm going to subtract the antecedents and add the result to the consequent. I'm going to write the given here again. We have A plus B over 3 equals B plus C over 6 equals C plus A over 5. I want to have A in the numerator from these all antecedents. So what I'm going to do is I'm going to subtract the first 2 antecedents, and when I subtract them, I'm going to add the result to the third one. So I am going to have A plus B minus B plus C plus A. And this over 3 plus 6, or I'm sorry, minus 6, I'm going to subtract here as we said before, plus 5. So I'm going to write it again. A plus B minus B minus C. I use the distributive property. And here is plus C plus A over 3 minus 6 plus 5. As you see, we have some like terms. So here is B minus B and negative C plus C. So we have double A. So this is 2A over 3 minus 6 plus 5, and 3 minus 6, which is negative 3, and negative 3 plus 5, the answer is 2. And this equals, of course, one of the ratios. And of course, I can simplify this one, so the answer is A over 1 equals one of the ratios. So I got the right-hand side, which is A over 1. And for A over 1, it's the same as A plus B plus C over 7. So I proved now that these two ratios are equal, I'm going to write them here. So we have A plus B plus C over 7, and this ratio that I got it for the right-hand side equals A over 1. Then this is the ratio that I got it for the right-hand side, and these two ratios equals one of the ratios which are written in the given one of ratios. And to write the required in the form which is written in the book, I'm going to write this a proportion in another way as A plus B plus C over A equals B over or equals 7 over 1, which is 7. This is another form for this proportion, and both of them is right. So this is what we have for exercise number 1.
All right, so now that we're done with this exercise, what are we going to do next? Do we continue the same unit test, or we move to something else?
We can go on some exercises on page 92. There are many exercises.
Page again?
Page 92 or 93.
92 or 29?
No, it's 92 and 93. Some
92
exercises
okay.
are here, and these exercises as a revision for every unit. So
yeah.
There are many exercises here.
So choose the best ones.
Okay, the best one, I'm going to work on the same idea that we studied here. Page 93, exercise number 14.
14?
Yes.
All right, so it's page 93, exercise 14. Yeah. All right.
And the question says, find the number that should be added to 7, 9, 12, 15 to be proportion. There are two ways to answer this exercise. I'm going to use the easiest one. I'm going to use the property that we studied now. We have a number and we don't know this number, so I'm going to put an assumption that let the number be x. And as we have here that this number, if we add it to these numbers, well, I'm going to form a proportion. So if we have 7 plus x and 9 plus x, 12 plus x, and 15 plus x, so this is a proportion of 4 parts. So I can write this as 7 plus x over 9 plus x equals 12 plus x over 15 plus x. Usually some students will use the cross multiplication strategy and solve this equation as this is an equation for second prep. But we have a property that we studied here that if we add or subtract the antecedents and the consequent, we have a new ratio, and this ratio equals to these two ratios. So for example, if we subtract these two antecedents, so we have 7 plus x minus 12 plus x over 9 plus x minus 15 plus x. So we have here 7 plus x minus 12 plus x. I'm going to write here 12 plus x over 15 plus x. I'm going to simplify. So 7 minus 12, the answer here is negative 5, and x minus x, they vanish together. And here's 9 minus 15, and the answer here is negative 6. And x minus x, so they will vanish together. So we have negative 5 over negative 6, or it's 5 over 6. Now it's simply to solve this proportion to find the value of x. I'm going to use the same property, which is the cross multiplication property. And instead of doing this here, I'm going to do it this as I have a proportion of 12 plus x over 15 plus x equals 5 over 6. I think it's more simple to solve this. Let's solve it in a new page. So we have 12 plus x over 15 plus x equals 5 over 6. Now, using the cross multiplication strategy, so 6 times 12 plus x equals 5 times 15 plus x. And this is strategy, the main name of this strategy actually is the product of means equals the product of extremes, but we use this nickname, a cross multiplication strategy, as some students know this property by this way. So I'm going to use the distributive property now. So I'm going to multiply 6 by 12, and the answer here is 72 plus 6x equals, and 5 times 15, which is 75 plus 5x. Okay, solve the equation. So here's 6x and here's 5x. So I'm going to write here x equals 75 minus 72. The answer is 3. So x equals 3. This is the number that if I add it to 7, 9, 12, 15, I'm going to form a proportion. And if you want to check your answer, just add 3 to these 3 numbers. So we have here 10, 12, 15, and here's 18. So this is what we have in this exercise. And if you want to check your answer, of course, the product of means here, 12 times 15, it's 180. And the product of extremes here, it will be also 180. So this is a proportion because 3 is the number that should we add to 7, 9, 12, 15 to form this proportion. For this exercise, maybe you have another exercise.
Same page?
Yes, in the same page, page 93. And let's work on exercise number 18.
18. All
Yes.
right, so it's exercise 18, page 93. Okay.
Okay. For
Different idea?
Yes, for exercise number 18, it says find the positive number if we add its square to each term of the ratio 7 to 11, it becomes 4 to 5. So we have a value, let this number be x. This is the first assumption because we have a positive number and we don't know what's this number. So we have here, if we add the square of this number, which is x squared, to the ratio 7 to 11, I have 7 over 11. So if we add x squared here and we add x squared here, the answer, it will be 4 over 5. A proportion of 4 terms. The product of means equals the product of extremes. So 5 times 7 plus x squared equals 4 times 11 plus x squared. Now, using the distributive property, and for the distributive property, I'm going to multiply 5 times 7, and the answer here is 35 plus 5x squared equals 4 times 11, which is 44, plus 4x squared. Solve the equation. Here is 5x squared and here's 4x squared, so this is x squared, and this is 44 minus 35, and the answer is 9. So we have 2 values for x. The first value is positive 3, and the other value is negative 3. And if the question asks me to find the positive number, I'm going to write only 3. And if the question asks me to find the negative number, so I'm going to write only negative 3. This is what we have in exercise number 18.
Okay, let us now move to another exercise.
Back to page 29.
Back to page 29, all right.
Exercise number 1.
Yeah.
Would you mind read
it
the
out,
exercise?
okay. I'm going to read it out. Again, it's page 29, exercise number 1. And it says, if y over x minus z equals x over y equals x plus y over z, then prove that each ratio is equal to 2 unless x plus y equals 0, then find x to y to z. Right.
2 required here under condition.
Yeah.
And the first required, I want to prove that these ratios is equal to 2 And the second required is I have to find the ratio between x to y to z, and we have a condition, a very important condition, that x plus y doesn't equal to 0. Now, the first part here, I want to find that, or prove that these ratios equals to 1. So I have 3 ratios and they form a proportion. And simply, all what I have to do to use the last property that we studied, if we add the antecedents of the 3 ratios and the consequence, we have a new ratio, and this ratio equals to one of these ratios. So if we have y plus x plus y over, as you see, I add y plus x plus y over x minus z plus y plus z, and this equals one of the ratios that we have here, equal to this one or this one or this one. Now let's work out on this. So we have x, y plus y, we have double y, plus x, we have double x, over. And here's negative z plus z, they vanish together, so we have down x plus y. And this again equals one of the ratios, as this is a very important property, we said it before. Now let's have a common factor up, so 2 times y plus x over x plus y, and this equals one of ratios. Let's simplify. So 2 equals one of the ratios, so this is what we proved now, that these 3 ratios equals to 2. As the operations that we did here, it's a property of the proportion, and every single addition or subtraction for the antecedent and the consequence gives me one of the ratios. So we got here that 2 equals one of the ratios, so this is the first required. Now, for the second required,
find x,
find
to y,
to z. Yes. As we see, we have y over x minus z equals x over y equals x plus y over z, and this is equals 2. So this means, for example, for this one, I can write that x equals double y. Now for x equals double y, I can work this ratio and replace this ratio on one of these 2 ratios. So I can write y over 2y minus z equals 2y plus y over z, and this is equals 2. And for example, if we add these ratios, we have here y plus 2y plus y, so we have 4y, and down 2y minus z, so we have 2y, and of course this will equals 2, so we got 2 as the same. So x equals 2y will help me now to find z, so I'm going to write it here. X equals double y, and we have y over x minus z equals x plus y over z, and this equals to 2. Now we have x plus, or y plus x plus y, so we have 2y plus x over x, because negative z plus z, and this equals 2. So using a cross multiplication strategy, so 2y plus x equals 2x. So 2y equals x, and this is, we got the same. So now the ratio between x and y is 1 to 2, as x equals double y. And now I got x to y to z.
Can we have a quick exercise, because we don't have much time left?
Okay, a quick exercise. Let me write an exercise here. if A over 3 equals B over 4 and B over 6 equals C over 3, and I want to find A to B to C. So how can I find A to B to C, as we have here two ratios or two proportion? For the first proportion, A over B equals 3 over 4. And for the second proportion, B over C equals 6 over 3. As you see here, that A over B equals 3 over 4 and B over C equals 6 over 8, or maybe equals to 2. I can write this in another way. B over C equals 2 over 1. Now, the main thing that I'm going to do here, that B here is the 4 times a factor, and B here it's 2 times another factor. But I want to write these two values. I have to make them the same. So B here is equals 4, so I'm going to write multiply here by 2, multiply here by 2 to write this proportion another way. So B over C equals 4 over 2. Now I can make a combining ratio between these two proportions, as A to B is 3 to 4 and B to C is 4 to 2, so I'm going to write here C. So B to C is 4 to 2, so I'm going to write here as 2. So I have here the ratio between A to B to C is 3 to 4 to 2, and this is what we have in this exercise.
All right, that's all the time we have for this episode. I'd like to thank you very much, Mr. Ashraf Ahmed Helmi, for your being with us and this beautiful explanation of this lesson. Thank you very much.
You are welcome.
So that brings us to the end of this episode. Dear students of the 3rd prep grade, we've had lesson 2 of unit 2, ratio and proportion. We've already done some exercises from your book. I hope it's been useful to you, and until we meet you again next week, inshallah, we wish you all the best. Goodbye.